Okay, welcome to your test review. Just a reminder, you do not have to watch this video or take notes on this video. I won't be grading you on that, but it is recommended. I'm not always going to give you test reviews, so a lot of times I'll just tell you to watch the videos that we've done the past week or so. Today I did decide to give a test review, so just pay close attention, and anything that you might have questions on, just come to tutoring and I'll help you out. So here we have an equation that we need to solve. So this is just a two-step equation. This will be from the first section of your book. So let's get going. So when you're solving equations, after you've combined all like terms and all that, you just need to remember that your goal is to isolate that variable, which in this case is an a. I know it looks like a 9, but this is actually an a. So our goal is to isolate to get that variable by itself. How do we do that? Second step, using inverse operations. So we have 1 plus a over 5, or a fifths, a over 5. We're going to want to get rid of this 1 first, because remember, we always, I guess you could kind of think of it as doing the order of operations in reverse. That's a positive 1. So to get rid of that, we would need a negative 1, minus 1. But whatever you do on one side, you have to do on the other side. If you do that, you're left with a over 5 equals negative 3. Now you just simply, this is a divided by 5, so we just simply multiply both sides by 5, which would be the inverse of division, and that would cancel these 5s out. Whatever you do on one side, you do on the other. Negative 3 times 5 would be negative 15, which would be your answer. So I forgot to mention this before, but as you're doing these, please just pause the video and try to work it out on your own before you actually watch me do it, and that way you really are certain that you can do these problems. So go ahead and read this problem, pause the video, try to figure it out on your own. So our variable is going to be t, or it could have used something else, but I'll just go ahead and use t. And t in this case would represent the amount of time it'll take both pumps working together to fill up one tank. So key word here is together. So we're going to have both pumps together. That's old pump and new pump. I'll put NP for new pump and the old pump working together. And when they're working together, we want to figure out how long it'll take them to fill one tank. So new pump plus old pump, and we're trying to fill one tank up. So we'll just put 1 over here. T stands for the time, the hours. We don't know that yet. That's our unknown. What do we know about the new pump? We know that the new pump can fill a tank in 5 hours. So if we put that in terms of just 1 hour, that means it fills up 1/5 of a tank per hour. And remember, per is one of your rate words. It's going to mean times. I put H, I'm sorry. I meant to put T, which is what we're using. So that means if T was 5, that would be 5 over 5, which would be 1, which that's how long it takes. It takes 5 hours for it to fill up one tank. And the old pump can fill it up in 7 hours. So if we change that in terms of just 1 hour, that would be 1/7 of a tank per hour. 1/7 of a tank per hour. Now we just need to solve this. We have the same variable here, so we could just add 1/5 and 1/7 by finding the least common denominator or by using a calculator. But in this case, the LCD would be 35. And if you add those up together, you would get 12 over 35t equals 1. That's 12 over 35 times t equals 1. So how do you get rid of multiplication? You divide. But remember, when you're dividing by a fraction, it's the same thing as multiplying by the reciprocal. So that's the same thing as saying, well, we're going to multiply by 35 over 12. That'll cancel out. We do the same thing on this side, 35 over 12. So that'll give us our answer, which is t equals 35 over 12. Change that to a mixed number, and you'd get t equals, that would be 2 and 11/12. And And that would be your answer. 2 and 11/12 of an hour would be your answer. Identify the terms and coefficients of each expression. So remember, when we have an expression like this, a term is anything that's separated with an addition sign. You could rewrite this using addition signs. That would just simply be 4.6w plus a -3 plus 6 4/10 times x plus 1 9/10 times y. And that might make it a little easier for you to kind of identify the terms. So what would the terms be? I'll just put T for terms. We have 4.6w, -3, 6.4x, and 1.9w. So those would be your terms. Now what about coefficients? Well, coefficient is the number factor of a term that contains a variable. So it would only apply to terms that contain a variable, not constants like -3. So your first coefficient would just be the number part. So it would only be 4.6. That would be your coefficient. Then we'd have 6.4 over here and 1.9. I'm sorry, this was supposed to be a -1.9. I apologize for that. So that would make this term -1.9y, and that would make this coefficient -1.9. I am sorry about that. But that was supposed to be a negative. Okay, so this one, write each as an algebraic expression. If any of these words confuse you, just study those those keywords that we discussed a couple videos ago. So D decreased by 16 is 15. So we know that decreased is going to mean subtraction. And we are subtracting D and 16. And we know that usually means equal. So that's going to be 15. D minus 16 equals 15. So if any of this confuses you, you really need to just study those keywords that we went over a couple videos ago. Okay, so here we have Frank buys P pounds of oranges for $2.29 per pound, and the same number of pounds of apples for $1.69 per pound. What does the expression 2.29 times P plus 1.69 times P represent? So obviously the 2.29P is going to represent the cost of the oranges. Oranges are $2.29 per pound. So 2.29 times the amount of pounds of oranges you get would give you the cost of oranges. And then the 1.69p would represent the cost per pound of, what was that, apples? Apples. So what would the entire thing represent? It would represent the total cost of the apples and oranges. So total cost of the apples and oranges, or the oranges and apples. And that's all you would need to write when you're taking this test. If you get a problem like this, that's it. That's all it's representing, total costs of the apples and oranges. Okay, again, I recommend that you please pause this video and try to work this out on your own before you watch me do it. Here it says Bill wants to rent a car. Rental car company A charges $35 per day plus 10 cents per mile. Per mile, per being a rate word, so that's obviously going to mean multiplication, or multiplying it by the amount of miles that we drove that day, and that'll represent how much we're being charged for our miles. And $35 per day, I mean, that would also depend on how many days we travel, but once you finish reading this problem, we'll notice that we're just going to focus on just one day. It's just going to be 35 plus 10 cents per mile. And then it says rental company B charges $25 per day plus 15 cents per mile driven. After how many miles driven will the price charged by each company be the same? So, the same, equivalent, that's the definition of an equation. An equation is when we have two expressions that are equivalent, that are equal. So we want both companies to be equivalent. We want company A to be equivalent to company B. That's what we're looking for. When are they going to be equivalent? So over here on the A side, let's write our expression. It says they charge $35 per day regardless of how many miles you drive. It's going to be $35. But then plus is going to mean add, they charge an additional 10 cents per mile, and mile is what we're looking for. How many miles would they have to drive before the amounts are the same? So we'll be multiplying that times M. That would be our unknown. That's what we're looking for. And then rental car company B charges $25 per day, plus they charge 15 cents a mile. So that would be 0.15 times M. And now you would just solve it. So you'd want to get everything on one side. So we'd want to make sure the M's were both on the same side. So it doesn't matter which M you move over. I'm going to go ahead and move over the 0.1 M. So we'd subtract by 0.1 M, and we'd do the same on the right-hand side, 0.1 M, and that would give us 35 on the right-hand side, and that's equal to 25 plus 0.05 M. Okay, then we would, this would just be a regular two-step equation. We'd subtract by 25, and we would be left with 10 equals 0.05 500ths times M. Oof, that's a horrible looking M. So I have to switch colors here because this side is white. So we would divide by 500ths. We'd have to do the same thing on both sides. Divide by 500ths. And for those of you that forgot how to divide by decimals, you're not going to be using a calculator. If it's easier for you to change that to a fraction, you can. If not, it's just as easy to divide by decimal. Just remember, we need to move the decimal point over twice to the right, which would mean that we'd have to add a couple we'd have to annex a couple zeros up in the numerator. So that would change this to 1,000 divided by 5 equals M. And that's easy. That's just 200. So after 200 miles driven, they would both be charging the same amount. And the last problem we're going to be looking at for this review video is literal equations. So literal equations are equations with more than one variable, normally formulas or whatnot. So in this case, you have x times k equals w minus v. X times k equals w minus v. And they want us to solve this equation for x. That means they want us to isolate x. They want us to get x by itself. So think about this the same way you would think about regular equations. You'd perform the same things. I know you'd be performing them with variables, and for some of you, that kind of messes you up because you're not used to that. You're used to just using numbers. But it's the same process, and the properties, the same properties still apply with variables because a variable is a number. It's just a number that we don't know yet. So if we're trying to get x by itself, it means we want to get rid of k. And it's x times k, so the opposite of multiplication would be division. We're going to want to divide by k. Why? Because even though we don't know what k is, we know that any number, or even a variable, divided by itself is going to be 1. And that's a property that's true for any number, even variables. Variables stand for an unknown number. So why do we want to change that to 1? The same reason why we would want to change it to 1 if it was a number, because then 1 times x would just be x. So the k's would cancel out. We'd be left with x. But whatever we do on one side, it's a law of equality, we'd have to do on the other side. We have to divide the entire thing by k. Now, can we divide w minus 7 by k? No, we can't. So that's it. We would just leave it like this. We satisfied this question here. We did what they wanted us to do because x is by itself. And x would equal w minus v divided by k. That's it. That's all you'd have to do. So that's the literal equation. If any of these problems were challenging to you, and you want some extra help, please come to tutoring at 8 a.m. on Friday, and I will help you out with any questions that you might have. If not, I will see you on Friday for your first test. Goodbye.